Welcome students. Today we will take chapter 2 polynomials. Let us define polynomial. Polynomial comes from poly. Poly means many and nomial means terms. Now, in mathematics, a polynomial is an expression consisting of variables, coefficients, and it involves operations of addition, subtraction, and multiplication. Division is not there, only these three operations will be there. We will learn about variables and coefficients, and we will also learn about exponents. You know what means exponents, powers. But in polynomial, we have non-negative powers. Negative powers of variables are not possible in a polynomial. Now, let us recall certain mathematical terms. What is a variable? Can you recall it? A variable is of a form x, y, which is an unknown number, which you have already seen in equations. Then, what are coefficients? Coefficients are numbers which are attached to the variables. So, I will explain these terms to you with examples. Let us learn about the concept of terms. Here I have provided you with many examples where you can see that here there is one term, here there are two terms, and in this part you can see three terms. How can you differ these three pictures? Just observe. Yes, on observing we are realizing that here there is no operation of plus or minus. Here we can see the operation of addition between these two terms. And here you can again see the operation of addition as well as subtraction between the terms. And so there are three terms over here. This I have even compared with the cycles form. How do we get the name monomial? You know monocycle, even you know bicycle, and you know tricycle. The same type of this names are given over here. Monomial, binomial means 2, and trinomial means 3. But here there are not wheels, there are terms. Monomial means one term, binomial has two terms, and there is, you can see, a sign of addition. Now can we have a sign of subtraction over here? Yes, both are allowed, addition as well as subtraction. But these are having two terms because you can see two terms on the either side of the operation addition. Here there are three terms because you can see three terms and the operation in between are addition as well as subtraction. So between these two terms there is the operation of addition, and between 3y squared and 7 there is the operation of subtraction. It means that the terms can be separated from each other by the operation of addition or subtraction, not division and multiplication. Because see, here there is multiplication, but it is representing only one term. 3 into x squared into y. So it's a product of 3x squared y. But still it is representing only one term. In order to differentiate two terms, we need the operation of addition or subtraction. And as the name goes, this is monomial. It is binomial because there are two terms, and the trinomial, there are three terms. Now, what about the polynomials which are having terms more than three? You can call them there are certain names over here: quadrinomial for 4 terms, quintinomial for 5 terms. So these are often not used. We usually call all these by name polynomials. It is easier to call them polynomials than to call them quadrinomial, quintinomial, all that. But definitely you can learn 3 names: monomials, binomials, and trinomials. So is the concept of terms clear to you? Okay, let's move to the next part. What are variables? Polynomials can have no variables at all. Like if this is the number 15, if you ask a first standard child, then he or she will tell that 15 is a number which comes after 40. But now you can say that 15 is a polynomial. It just has one term which is a constant. So see the same 15, but in ninth class you are seeing with a different view. In a first class child will see it as a number and you will see it as a polynomial. Which type of polynomial it is? It is a constant polynomial. Why? Because it is not having a variable. What means variable? Variables are the alphabets like X, Y, Z, any alphabet, but they should be written in small letters. Usually you commit the mistake of writing in capitals. So be very careful, they should be in small letters. Now here we are seeing that there is no such variable. No alphabets are seen over. It's simply a number. A simple number is a constant polynomial. Now here you can have another part of polynomials, that is you can have one variable. A polynomial can have one variable. Like in this example, you are seeing the variable y. Then you are seeing only the powers of y over here. No other variable is there. You are not seeing x or any such variable. You are seeing y, then the whole polynomial is made up of y. Minus 2 y squared plus y. The entire polynomial is made up of only one variable, that is y. And the third part is that the polynomial can have 2 or more variables. So there are 3 broad categories: either no variable, or one variable, or 2 or more variables. Now here you are seeing there are 2 variables in this term: x into y raised to 4, and here you are again seeing 2 variables in this term: 3 x squared z. So first of all, let us understand how many terms are there. There are 2 terms. How did we make it out? Because there is the operation subtraction in between. So I told you previously that the 2 terms can be separated either by addition or by subtraction. Here we have separated the 2 terms by subtraction. Now on the left side you can see the term is having 2 variables x and y. On the right side you are seeing the term having 2 variables x and z. Overall we can say that this polynomial is made up of 3 variables x, y, and z. What about this polynomial? How many terms are there? Yes, there are 3 terms. How did you make it out? Because you are seeing that first and the second term is separated by the operation subtraction. So first term, second term. And what about the third term? It is separated from the second term by the operation addition. So altogether there are 3 terms. But this polynomial is different from this polynomial y, because here there is only one variable, but here there are 3 variables. Here we need to recall the definition of polynomials to separate a polynomial from not a polynomial. So first, what is a polynomial? It is made up of terms. Here you can see there are 4 terms. How did we understand there are 4 terms? Because in between 2 terms you are seeing the operation subtraction or addition, which I told you previously that 2 terms can be separated with the operation of addition or subtraction, but not the product. You can have the operation of multiplication within the term, but it cannot separate this term from this term. Say for example, if there is the operation of multiplication, then this both will be considered as only single term, right? So a polynomial consists of 3 operations: addition, subtraction, and multiplication within the term. Here you are seeing exponents. What is the exponent of y? It is 2. What is the exponent of x? Some of might may say 0, but that is wrong. The exponent of x is 1. Here again the exponent of x is 1. The exponent of y is 3. And what about this constant term? Here the exponent is 0. Like if you say there is a variable x, then the exponent is 0. X power 0 is 1. Hence, you are not seeing the variable over here. You can say that a variable is hidden over here. Which variable? X power 0 or y power 0 or x power 0 into y power 0. Everything will result into 1. X power 0, y power 0 is 1. Do you remember the rule of exponents? A power 0 is 1. So, again, a polynomial is made up of variables. Which are the variables over here? X and y. Coefficient. Can you recognize the coefficient in first term? Yes, it is 5. What is the coefficient of second term? It is 3. Minus 3. And what is the coefficient of third term? 5. And the coefficient of the fourth term is minus 3. So again it is made up of variables, coefficients, terms, exponents. But now the crucial concept lies that the exponents should be non-negative and the variable cannot be in division. The variable cannot be in the denominator, in the division. And the exponent can never be negative. The exponent cannot be even fraction. So let us understand it one by one using an examples. Now here you are seeing the example 3xy power minus 2. It is not a polynomial. Why? Here the exponent is negative. You just go to the definition of polynomial in the first slide. It is clearly written that the exponents are non-negative integers. Non-negative integers means positive integers. And integers means fractions are not allowed. The hidden concept that fractions are not allowed is already understood by writing that they are non-negative integers. It means fractions are not allowed. And a variable in the denominator is also not allowed. You can see the first definition of polynomials, first slide. All these things are written. And this is explained over here using an example. Now here this is not a polynomial because the exponent is negative. Why this is not a polynomial? Just guess. Yes, here the variable is in the denominator. It is not allowed. Variables in fractions are not allowed. Let's move to the further rules of polynomials and non-polynomials. Now these are polynomials. 3x, it's a monomial. This is a binomial. Here you can see many terms, 1, 2, 3, 4, 5 terms. So polynomial. Again here you can see two terms. The powers are positive integers like 5 and 5. They are not negative integers. So it is a polynomial. Here you can again see the power of y is 2, which is a positive integer. Power x is 1, which is a positive integer. Here the power is not written, it means it is 1. And 1 is a positive integer, hence this is a polynomial. Now a question will arise to you that then what about this minus 6? We are talking that positive integers, then minus 6 is negative. But a coefficient can be negative. The power of variable should not be negative. The power of variable should be positive. 5. 5 is also a polynomial. We already learned it is a constant polynomial. Now let us move to non-polynomials. Here it's not a polynomial because the exponent is having a negative integer, minus 2, which is not allowed. The exponents can only be 0, 1, 2, 3. 0 is allowed because x power 0 is 1. So it's allowed. Now here x upon 2 is allowed because you can divide by a constant. So if you are dividing the polynomial by a constant, then it is allowed. Because in the denominator, variable is not there, only number is there. But here you see, on the contrary, compare this and this. So on the contrary, over here you are seeing in the denominator you are having a variable which is not allowed. If there was only 2, this part was not there, and if the denominator was going to have only 2, then it was allowed. But here you are seeing the variable. Variable is not allowed in the denominator. So this is not a polynomial because dividing by a variable is not allowed. Here 3x upon 8 is also a polynomial. Why? Because here 8 is a constant number, a constant term also you can call. But 1 upon x is not allowed because here in the denominator it is a variable. So understand the difference between x and 8 in the denominator. Root 2 is allowed because it is the constant, like it is equal to 1.4142, right? Because it's having a value. Root x is not allowed because the exponent is half. Half is again a fraction, and you cannot have fraction as exponents because they are supposed to be only positive integers. I told integers itself means fractions are not allowed. If you have written 2 raised to half, then it was not allowed. But if you write this value, then it is allowed. What is the degree of a polynomial? The degree of a polynomial with only one variable is the largest exponent of that variable. Now, if this is the polynomial and it is having only one variable, which variable is it? X. Then you just compare the powers of all the terms. This is the first term, its power is 3. This is the second term, its power is 1. And here the third term is constant term, means you can say that x power 0 is there, which is hidden over here, and we need not care about it because we are already having the highest power 3. So degree of a polynomial with one variable is the largest exponent of that variable. So which is the largest exponent? It is 3. And hence the degree is 3. Let us take other examples. You will understand clearly. Now a degree of the polynomial is the highest of the degrees of the monomials with non-zero coefficients. Right? So here, let us take the first polynomial, a constant term. I already told you that a constant term is having a hidden variable with power 0. See, it's already written over here. Degree 0. What can be over here hidden? You can write 1 into x power 0. X power 0 is 1. This rule you already studied in lower classes in powers and exponents. Which rule? A power 0 is 1. So x power 0 is 1. So 1 into 1 is 1. So what is the power over here? It is 0. Hence the degree is 0. In this linear equation, a linear polynomial, why we call it a linear? Because here the degree is 1. When the degree is 1, it is called linear polynomial. And it is a very famous polynomial. Linear polynomials are very famous. So, what means linear polynomial? Here, it is the polynomial should have one variable only, right? And the degree of this polynomial is 1. Why? You see x power 1 is the highest exponent in this term 2x. 2x power 1. In this term you are having the highest exponent plus 1. 1 means here the exponent is 0. So highest exponent is 1. Therefore the degree is 1. Here the highest exponent is 2. Hence the degree 2. It is called quadratic polynomial. In cubic polynomial, you can see the highest exponent of this is of this term. You have to even find out which term is having the highest exponent. This term 4x cubed is having the highest exponent. Hence the degree of this polynomial is called 3. Now do you realize what words I am using? I am using degree of the polynomial and exponent of the term. Okay, now quartic polynomial is having the degree 4. The polynomial is having the degree 4 because the exponent, the highest exponent is in this term. 5x power 4 is having the highest exponent. Hence the degree of this polynomial is 4. The degree of a non-zero constant polynomial is 0, which I already explained you over here. So let us summarize again what a polynomial can have. It can have constants. In constant, fraction is allowed. In constant, negative integers are allowed. Everything is allowed in constants. It can have variables. The variables can be x, y, but they should have small letters. Then a polynomial will have exponents like y squared. So the 2 in y squared is the exponent. And exponents are only positive integers. Then a polynomial is having terms which are combined using addition and subtraction, right? And multiplication and division except non-division by a variable. So something like 2 upon x is not allowed, which I already explained you previously, that you can divide by constant term. That's why they have written over here division. Division is having exceptional cases also, like a division of variable is not allowed, but a division of constant term is allowed. We saw this in the previous examples. A polynomial can have constants, variables, these are variables, exponents, here is an exponent, but never division by a variable. This is not allowed. Division by a variable is not allowed. I have taken the constant polynomial topic separately. What are constant polynomials? A term with no variables and a polynomial with no variables are called respectively constant term and constant polynomial. If the term is not having a variable, like 5 is one term with no variable, hence it is called a constant term, and it is also called a constant polynomial. So we can call 5 as constant term also and constant polynomial also. The degree of the constant term of the non-zero constant polynomial is 0. So if we take the example 5, then the degree of its variable is x power 0, which was hidden. Hence the degree of constant polynomial is 0. Here we are having the standard definition of a polynomial. A polynomial can be an expression of this type: an x power n plus an minus 1 x power n minus 1 up to an x plus a0. Here an, a1, a2, all these are constants, and an is not equal to 0. Why? Because if an becomes 0, then the entire polynomial will shrink to 0. So if we want a polynomial of certain degree, like n, now let us take that degree 1, then here we'll have x power 1. If we have x power 1, then an cannot be 0, otherwise how can we write the degree? We are going to write x power 1. X power 1 can be written if an is not 0, it means an should have certain value, certain number, like 3, 2, 1, like such constant numbers should be there. So this is the standard form of a polynomial. Now let us understand what is a zero polynomial. I just told you that an cannot be 0, but just assume that if an is 0, as you can see here, if an also becomes 0, means everything is 0. If everything is 0, you can see all the constants are 0, then the whole polynomial will shrink to 0, and the degree of such a polynomial is not defined. Because 0 cannot have any degree. It is not defined. A constant term has a degree. What is the degree of the constant term? Like if we took in the previous slides a number 5, then what is the degree of the number 5? Just guess out or visit the previous slides. It is having a degree, but 0 is not having a degree. Like you can see, it is not defined. Now, what is special about polynomials? We can add polynomials to get a polynomial. We can multiply polynomials to get a polynomial. We can do lots of additions and multiplications. Still we can have a polynomial. But if we divide polynomials, the result may be or may not be a polynomial. The standard form for writing a polynomial is to put terms with the highest degree first. Now this is not in the standard form. So you understand the standard form properly, because when you are doing the sums, you have to first arrange them in the descending order of the exponents. That is called standard form. It means the highest degree is 6. It should come first, and then the exponents will move in the decreasing order. So it has, as you can see, 3x squared minus 7 plus 4x cubed plus 6x raised to 6. Here x raised to 6 is the highest degree. So it should arrive in the first. The term should be first. X power 6 should become the first term. The next term should have the power 3, because it is the next lower degree. And then the third one should be 3x squared. The third term should be 3x squared, because again the power 2 is lower than the power 3. And finally the constant term should be there. This is called standard form for writing a polynomial. So children, we have discussed about the basic concepts of the polynomial. It is going to be a great help to you in the videos that will follow in this chapter in successive parts. Thank you.